Our next type of reaction is a double replacement reaction. Much like single replacement, where you had a compound made up of two and then a single ion or element, now we're dealing with two compounds, and they could be either ionic or covalent, and ultimately what we're going to see here is a partner swap. This happens a couple different ways. One of the most common is an acid-base neutralization. That's where you have an acid and a base that get mixed together, and they react to form a salt and water. The other common one is when you have what's called a precipitation reaction. So you have something that's dissolved or something that's in a liquid, and you mix a solid in, and then the solid goes into the liquid, and it kicks out a new solid. Either way, what we see here is we see an attempt to create something more stable than what we had originally. That's why the acid-base neutralization is so common, because by creating water as one of your two products, as we discussed in decomposition and single replacement, you're making a more stable product than what you had beginning, and that's what motivates and allows the energy to work in your favor. It's what drives the reaction towards the finish line. For this first example of a double replacement reaction, we're going to look at two ionic compounds, potassium chloride and sodium bromide. Now, potassium chloride and sodium bromide, each individually, are somewhat happy and stable. Right? The positive and negative ions have balanced each other out, and they've managed to settle down and meet their needs for electron stability. But when they're put near each other, there is a way that they could reform that would make them more stable. And so what happens is they first reionize. So the first thing we see is that they break apart from their previous formations, and now they're just potassium bromine, sodium, and chlorine. Then they shuffle around, essentially doing a partner swap. Ant-Man was with Gamora, but she moves over here. She-Hulk joins Ant-Man. And Gamora goes back with War Machine. Notice that in the partner swap we started with one metal and one non-metal, or green non-metal. Right? Ant-Man and War Machine didn't become partners. They'd both still be positive ions, they wouldn't match together. Gamora and She-Hulk didn't become partners. Right? They swapped one metal for another. But now we have potassium bromide, and more importantly, the very stable and happy sodium chloride. And that's your double replacement. For our second example of a double replacement reaction, we're going to look at a very common acid-base neutralization. Here, we're going to begin with a strong base, sodium hydroxide, and a strong acid, hydrogen chloride. The sodium and chloride are War Machine and Gamora again, as they were in the previous example, and we brought in some agents of S.H.I.E.L.D. to be our hydrogens and oxygen. So, when the acid and the base combine, they immediately react. What that means is that they start breaking apart right away into their individual components. So now instead of having sodium and chloride, we have chlorine ions, sodium ions. We have our oxygen and our two hydrogens. Now, once everything is ionized, things are going to react to create their most stable formations. And in the presence of hydrogen and oxygen, we know the most stable thing they can immediately become is for them to drift together. And form water. That leaves just sodium and chloride left, and they very happily will join together to make your sodium chloride. Now again, everyone's leaving with a different partner than who they came, right? But everyone is in a happier, more stable formation now. Acid plus base makes salt and water.